This part we are going to learn about polymorphism in C++. Polymorphism is one of the core principles of object-oriented programming. The word polymorphism means many forms. Okay, so polymorphism allows the same function or method name to behave differently depending on the object that is calling it. Okay, so this makes programs flexible and easier to extend. So let us take a look at the types of polymorphism. So there are two main types of polymorphism in C++. We have the compile time polymorphism and the runtime polymorphism. So in this part we will take a look at both briefly. Okay, so let us take a look at the compile time polymorphism. So compile time polymorphism is achieved using function overloading. Okay, so let us take a look at this example. I'm going to explain after writing. Okay, so here let us create a class. This class, let me name it math. Okay, so we don't forget to add a semicolon. Then inside we are going to have tab public, then tab. We are going to have we are going to have two methods. So this one is going to return a integer, and inside we are going to have two parameters, int a and int b, and from there let us give it a body. So from there we are going to return and then we add b. Okay, like that. Okay, then we are going to have another one. This one is going to return a double. Then we are going to name it also add. Okay, we are going to have a double. Instead of int a, we are going to have double a, and we are going to have another one which is double b, and we are going to give it a body, and we are going to return a then plus b, like that. Okay, so from there let us try to create our first object from our math class. So it's going to be called m, and that m we are going to try to output something. So we are going to use cout. We are going to call our m dot add. Okay, this one if we try to provide here, as you can see, so by default VS Code is telling us, the extension that we are is telling us that we are using the one with the doubles. Okay, the one that requires double parameters. Okay, but if we try to provide integers like 3 and 4, like that, as you can see, if I try to add a semicolon, okay, like that, and I try to hover over, as you can see, we have changed, okay, to that one, okay, which requires integers. So as you can see, +1 overload. Okay, so as you can see, we have changed. Okay, so and if we try to call another one, let us end our line like that. Okay, move the cursor to the next line, and we try to output also m dot, we call add. Okay, so as you can see, we now have this one, and if I try to provide the doubles like 2.5, and also I provide 1.5, like that, and I try to hover over this one, as you can see, the one we are using is the one with the doubles. Okay, the doubles. Okay, so same function name add. Okay, as you can see, is the one that we have used right here, as you can see. So here they require different parameter types. Okay, and compiler decides which version to use. Okay, it decides which version to use. Okay, so let us now take a look at the runtime polymorphism. So here the runtime polymorphism is where we use virtual functions. Okay, so runtime polymorphism is achieved using inheritance and virtual functions. Okay, so let us take a look at this example. Here. Let me fold this class like that. Okay, and then I'm going to move our function onto another line, and then in between we are going to create another class, a class called animal, like that. Don't forget to add a semicolon at the end. Then inside we are going to have public, then we are going to have a virtual. There is a keyword called virtual, like that. Virtual, press enter. As you can see, virtual, this is going to be void. Let me name it sound. It's going to return void, and it's called sound. Then inside we are going to output, use cout, then we are going to output animal makes a sound like that. We add a semicolon at the end. Okay, so from there, what are we going to do? We are going to create another class, but as I told you, here in the runtime polymorphism, we use inheritance and virtual functions. Okay, so here we have used a virtual function, and let us try to use inheritance. So we are going to create another class. It's going to inherit something from we are going to use public inheritance, and we are going to inherit from animal. Okay, like that. Don't forget to add a semicolon because this is a class. Okay, so from there, what are we going to do inside our doc? We are going to have a public void, and this one is going to be called also sound, like that. Okay, then from there, we are going to have cout a dog box. Okay, we're going to have dog box, like that. Okay, then we add a semicolon at the end. Okay, then from there, inside our main function, let me delete these lines. Inside our main function, we are going to create our animal object. Then we are going to use asterisk. I'm going to explain this. Then we are going to create our first animal called a. Then from there, we are going to create another. This is like a reference. Okay, so let me explain. So the base class pointer points to the derived object. Okay, and the virtual ensures a corrective function is called. Okay, so here we are using the base class pointer, which points to the derived object. Okay, so from there we are going to create our dog, and let us name it D, add a semicolon. Then from there we're going to say that a is equals, but we want the reference of D, like that. Okay, then from there we are going to get a. Can we access? So we can access the sound, like that. Okay, so we use dash instead of using dot sound, like that. As you can see here, have virtual void. Okay, so instead we can use like that to get access to our method. Okay, our method, like that. So we want to access sound, like that. Okay, so from there we can return success. So if I try to compile, believe me, we are going to get dog box. Okay, so if I try to compile, after compiling, I try to run. As you can see, we get dog box. But what if we try to use dot? Let's try to use dot sound. If I try to save, as you can see, we are going to get an error. Expression must have class type, but it has type animal, then asterisk. Okay, so as you can take a look at that. So as you can see that. So if we want to get this one, which is the new version of sound, then we should do something like this. Okay, so from there we try to do something like this. So dash, then we point to our sound. Okay, so let us take a look at why virtual functions are important. Okay, so without the virtual keyword, the base class function would be called instead. Okay, so the base class would be called instead, which is the base class function. Okay, not the class, the base class function, which is this one, would be called instead. And virtual functions enable dynamic binding. Okay, so these are somehow advanced topics, but yeah, don't mind too much about them. Okay, but they are very important. Okay, you will get to know to master them in future parts. Okay, where I'll be releasing multiple tutorials, okay, about C++ advanced concepts. Okay, so let us now take a look at real world analogy, because so that you can understand. So think of a remote control. Okay, so the same button behaves differently. Okay, so depending on the device it controls, that is polymorphism. Okay, so a remote control has a button, okay, buttons, okay, or a button which behaves differently depending on device it controls. Okay, So that's what we call polymorphism. Okay, so let us take a look at the benefits of polymorphism. So polymorphism helps us write flexible code, reuse code changes, reduce instead of reduce okay code changes, and improve scalability. Okay, so that is it. So in summary, polymorphism allows one interface to have many forms, and we learned about compile time and runtime polymorphism with some examples. And polymorphism is powerful, okay, and that's why C++ is really a great programming language. Okay, so if you enjoyed this part, like, subscribe, and I'll see you in the next part. Okay, thank you.